Good evening, class. Welcome back to PPS online class. Yesterday we started our fifth unit and we completed the searching concept from your fifth unit. So we discussed uh, these things. Our fifth unit we said we need to discuss about searching and sorting, and we also need to discuss about the complexity of algorithms, order of complexity of algorithms. So in these three topics, the searching thing we have completed in yesterday's class, and in today's class, most probably we will discuss about the algorithms. Okay, basic algorithms. So this particular topic, searching, we have completed. We discussed the first linear search and binary search, and in today's session hopefully we will discuss about the sorting algorithms, and we have three different types of sorting algorithms. In that, the first one is bubble sort, then we will discuss about selection sort, second one, and a third one, insertion sort, we will discuss. Okay, one by one we will discuss, and before that we need to know what is sorting and how we perform sorting and on an array of elements. Okay, given a list of elements, that is nothing but array of elements, how we perform sorting, that we need to discuss. Okay, after that we go for algorithms, bubble sort, insertion sort, and selection sort kind of algorithms, and we also demonstrate to program how we perform bubble sort, how we perform insertion sort, and how we perform selection sort, hopefully. Okay, so I'll take you to the sorting slides. So these are all we have completed in yesterday's session. Searching, two types of searchings, that is linear sequential search as well as the binary search, we have discussed in yesterday's session. So now the sorting, and it is also another important application, common application in computer science. Common computer science application, that is sorting. And generally what we do in sorting, in the sense we will arrange the elements. Okay, we'll try to arrange the elements according to their values. Okay, based on the values what we have in the array elements, we'll try to arrange them either in ascending order or in descending order based on our requirement. Based on the problem requirement, we'll try to arrange them in a particular order. That is what we call sorting. Sorting is nothing but sorting is a process through which data are arranged according to their values. Okay, ascending, we know that only two types of sortings we know: ascending order, arranging the items in ascending order, and arranging the items in descending order. So ascending order in the sense smallest to big, and descending order in the sense biggest to small. Likewise, we arrange the elements. Okay. So what type of issues? I mean, why we have to go for sorting? What is the need of arranging the items in a particular order? Okay, what type of difficulty we face if the items are not arranged in a particular order? Okay, so that we will discuss here. See, if the data is not arranged in an order, it will take hours trying to find a single piece of information. Okay, from the data to retrieve information, you need to take uh, hours of time before you find whatever you are insisting or whatever you are requiring. Okay, so that type of difficulty we come across if the data are not arranged in a particular order. So that's the reason we have to go for sorting. So take an example to better understand that one. So if the take the telephone directory, we all are quite familiar with telephone directories where we have different persons numbers. Okay, nowadays maybe you are unaware of telephone directory because we are all using smartphones, but people used to depend when we have only landline phones. People used to depend on this telephone directory a lot to check the person's numbers. Okay, different persons numbers who are all living around you, okay, in your city. So in that telephone directory, how the names and numbers will be stored in the sense in the person's name alphabetical order. Okay, all the numbers will be stored in that saved in that telephone directory. It is a book kind of thing, telephone directory. So in that all the numbers will be saved, all the numbers are printed according to the person's names alphabetical order. So if those names are not printed as per their names alphabetical order, if they are printed randomly, means it will take a lot of time before we find the person's name. So the type of difficulty we have if your telephone directory is not in a sequence. Okay, if it is not in a name sequence, then that type of difficulty we may face. Okay, so finding a person's name if the telephone directory is not ordered in the name sequence is a difficult job. So we can imagine if the items are not arranged, not sorted, what type of difficulties we may also face in computer science. Okay, so that is the requirement of sorting. Okay, so generally how we perform sorting in the sense sorting, it is a combination of two different operations. We basically perform two different operations when we do sorting, and the first one is the comparison. Okay, compare operation, and then swap operation. So whenever we do comparison, we check for their order, whether they are in order or out of order. Okay, if they are in order, we don't do anything. If they are out of order, we perform swapping to rearrange them. Okay, we perform swapping to rearrange them. Suppose take an example, we have two numbers, say 32 and 46, and say 24 also. So now when we compare this 32 and 46, they are in order because 46 has to come, if you are going with the ascending order, 46 has to come after 32. So it is in order, so no need to swap, we just leave them as it is. But when we compare this 46 and 26, they are not in order. As you can see, they are not in order. 24 has to come before and 46 has to come after. So what we do here, we perform swapping. Swapping in the sense we will interchange these two values. Okay, we will interchange these two values. So 46 will go here and 24 will come here. Likewise, we perform swapping. Okay, generally we denote like this. Swapping operation we denote like this. So 24 has to come here and 46 has to go there. Likewise, we perform swapping. So it is a combination. Whenever we say sorting, it is a combination of two different operations. First is compare and then swap. Okay, in the comparison operation, what we do, we compare two different values of the array, and in the swapping operation, what we do, Yeah, here I mentioned that statement also. From here to here you can read. After comparison, based on the requirement, the values are swapped. Why I am saying based on the requirement? Because it is not required to swap the elements all the time. If they are in order, no need to swap. If they are out of order, then only we need to swap. Okay. Swapping is nothing but what? Interchanging the values in elements of array. So basically, whatever storage we are using to store these elements, we use array only. Okay, and these boxes will become your memory locations, and we have 32, 46, 24 as values. So if they are in order, no need to swap the array elements, and if they are out of order, we need to swap the array elements. So what we have to do after swapping, how it will go? This 24 will come here and 46 will come here. Likewise, we need to perform the swapping. Hope you understood this concept. Okay, we'll go to the next slide, and the first sorting algorithm that we have here is a bubble sort. Okay, totally three different sorting techniques we will discuss, including bubble sort. The first one is, as it is mentioned there, it is bubble sort. Bubble sort. Second one, we go with the selection sort. Selection sort, and lastly, third one we discuss what it is, bubble sort, selection sort, and finally insertion sort. Insertion sort. So these three techniques we need to discuss before we conclude today's session. Okay, so hopefully one by one we will discuss. The first one, as you can see, bubble sort. The concept is very simple over here. In bubble sort, what we do, yeah, the complete given list, whatever array of elements they will give, that complete list we divide into two partitions. Okay, two lists. Okay, two sublists. We can call it as two sublists, and one side of the partition will have the sorted sublist, and the other side of the partition, take it like this, it is an imaginary wall. Partition is nothing but it is a kind of wall, and we call it as imaginary wall. Okay, this term we need to use, imaginary wall. Okay, the complete list will be divided into two sublists. One we call it as sorted sublist, sorted sublist, and the other one we call it as unsorted sublist. So from here to here, as you can see, from here to here it is sorted sublist, and from here to here till end it is unsorted sublist. Unsorted sublist. Okay, unsorted sublist. So what we do here is we try to perform the comparison operation and swapping operation from the end of the list. In bubble sort algorithm, we perform the comparison and swapping from the end of the list. And how we perform comparison and sorting, in the sense, always we try to maintain the smallest element on your left hand direction. Okay, we will try to push the smallest element towards the beginning of the list. Left hand direction is nothing but towards the beginning of the list. So in unsorted list, what we do, we perform comparison and swapping operation from the end of the list. Okay, ఇక్కడ నుంచి perform చేస్తాం. End of the list ఇది కాబట్టి ఇక్కడ నుంచి perform చేస్తాం. And whenever we found the what we call smallest element on the right side, we try to push it towards the left side, such that we push the smallest element such a way it should reach the beginning of the list. Okay, when we do it, you will understand. Just you remember the concept for now. What we do, we divide the given list into two sublists. One is sorted, one is unsorted, and between the sorted unsorted we'll maintain a wall, and we call that wall as imaginary wall. And every time what we do, in every pass what we do, see here, whatever operation we are performing, we call it as a pass. Pushing the smallest element to the beginning of the list, we call it as a pass. So in every pass, what we do, we push one item, one smallest item from the unsorted sublist to the beginning of the unsorted sublist. So once the pass is over, What we do, we move the wall. We move the wall one element ahead. We move the wall, we move the imaginary wall one element ahead, such that that element will be pushed from unsorted list to sorted list. That element will be shifted from unsorted list to sorted sublist. Okay. So doing moving the imaginary wall will, what it will do, ma? Moving the imaginary wall one step ahead, what it will do? It will increase the number of items by one in sorted list, and it will decrease the number of items by one in unsorted sublist. So that is what we do, ma. So, so concept is very simple, ma. మీరు ఇలానే రాయాలి ఎగ్జామ్ లో కూడా వాట్ ఎవర్ ఐ హావ్ గివెన్ ది ఎక్స్ప్లెనేషన్ నా ఇన్ దట్ వే ఓన్లీ యూ హ్యావ్ టు రైట్ హియర్ దట్ కంప్లీట్ ఎక్స్ప్లెనేషన్ స్టెప్ బై స్టెప్ ఈస్ గివెన్. So as you can see, the first step in the bubble sort algorithm, the list is divided into two sublists: sorted, unsorted. We are dividing the list into two sublists. Okay, the smallest element in unsorted sublist is bubbled and moved to the sorted sublist. Okay, what we are doing, we are bubbling the smallest element from the unsorted sublist and we are moving that to sorted sublist. Likewise, so after moving the smallest element to the sorted sublist, the imaginary wall, see here, the imaginary wall, this term I used over here. So the imaginary wall moves one element ahead. So one element ahead. So doing so will increase the number of sorted items and decrease the number of unsorted items. Okay. So every time we are moving the imaginary wall one step ahead by increasing the number of sorted items and decreasing the number of unsorted items. Okay. Moving one element each time from sorted sublist to unsorted sublist, we call it as one sort pass. This term also I used. One sort pass we have completed. Moving one element from sorted to unsorted, sorry, from unsorted to sorted, we call it as one pass we have completed. Okay. So how many passes you need to sort a list of n elements, in the sense, if a list with n elements is given, how many passes you have to, how many sort passes you have to take before you get the sorted list, final sorted list, in the sense, in bubble sort algorithm, in the sense, n minus 1 sort passes. So such iterations, whatever iterations we said now over here, such iterations, how many iterations we need? N minus 1 iterations, n minus 1 sort passes we need. Sort passes we need before the list gets sorted completely. Okay. So this last point, remember the bubble sort algorithm starts from the end of the list. From where we are starting, our algorithm? From end of the list. I already told you, always the bubble sort algorithm will be applied from the end of the list. Okay, we have an example demonstration, an example demonstration in our next slide. So quickly go there and hope you understood the terminology. What do you mean by imaginary wall? What do you mean by sorted sublist? And what do you mean by unsorted sublist? And how we are pushing one smallest element from the unsorted sublist to the sorted sublist. That and all, hopefully you understood. Okay, so quickly go and see the numerical example for this bubble sort algorithm. So this is the numerical example for bubble sort algorithm. So this is your original list, whatever original list they have given. Here we have that original list with how many items? With 6 items we have. So total how many n will become? Total how many items? 6 items. So how many passes it requires before we get the sorted list? N minus 1 passes. Okay, n minus 1 sort passes it requires before we get the final sorted list. Okay, final sorted list. So n minus 1 in the sense, how many sort passes? 5 sort passes. So only 5 sort passes it will take. With 6 elements, it will take 5 sort passes before you get the final sorted list. So as you can see, this is first sort, second sort, third sort, fourth sort. At most it will take 5 sort passes. At most it will take 5 sort passes but here in 4 sort passes only our list got sorted. Okay, our list got sorted. So whatever n minus 1 sort passes we are saying now, that is at most. Okay, in a worst case we can say at most 5 sort passes it will take, but in 4 only we got the sorted list for this particular example. Hopefully you understood. So as you can see here, our complete list, it is divided into two. Yeah, here we have to say divided into two only, because at the initial stage, before you applied any sort pass or before you applied any kind of logic in your algorithm, your sorted sublist will hold 0 elements. Sorted sublist lo ఎన్ని elements ఉన్నాయమ్మా ఇక్కడ? Sorted sublist lo, as you can see here, we have no element or 0 element, and your imaginary wall, where it is standing at the beginning of the list. This is your imaginary wall, whatever I was talking about. This is your imaginary wall, and this imaginary wall, as you can see, it is standing at the beginning. Okay, before you have applied any sort pass, the imaginary wall is standing at the beginning, and your sorted sublist is having 0 elements, and your unsorted sublist is having all 6 elements. Unsorted sublist is having all 6 elements. So now what we have to do, we need to apply the our algorithm. So how we said, how we need to apply? First we need to compare the we said now your bubble sort will start from end of the list, and this particular point is end. Okay, from here we need to apply the bubble sort algorithm. So what we do, we first compare the last element and last but one element. These two we compare. These two compare cheyandi. And which one is small, between these two? 32 only small. So don't swap anything. If I mean, we consider these two as in order. Okay, because our intent over here is to push the smallest element to the beginning of the list. అర్థమవుతుందమ్మా? స్మాలెస్ట్ ఎలిమెంట్ ని మనం ఏం చేయాలి? బిగినింగ్ ఆఫ్ ద లిస్ట్ కి పుష్ చేయాలి. Okay, to do that one, always whenever we get smallest element on the right hand side, we need to swap. Right hand side manaku smallest element ochindante, we need to perform the swapping. But over here we have the largest element on the right hand side and smallest element on the left hand side when we perform the comparison. So no need to swap anything. Okay, keep them intact. Okay, keep them as is. Okay, keep them as is, and don't interchange anything, don't swap anything over here. So next what we need to do, we need to compare, we need to take one more item into consideration, and we need to compare these two. Now we are comparing what? We are comparing 8 and 32. Okay, we are comparing these two, 8 and 32, and again your largest element between 8 and 32 is on the right side, and the smallest element, that is 8, is on the left side. So again, no need to, one more time, no need to swap the elements. Okay, just continue and take 45 also into consideration and compare 45 with 8. Okay, now we are comparing 45 and 8. Then we found that 8 is smallest and it is on the right hand side, and 45 is largest and it is on the left hand side. So what we need to do, now we need to perform the swapping, because they are not in order. So we need to perform the swapping. So just what will happen after swapping, your 45 will go here and your 8 will come here. 8 will come here. Now between these two, once again we need to continue, and between these two we need to perform, between 78 and 8 we need to perform the comparison. Again 8 is smallest and it is on the right hand side, so we need to perform the swap. So wherever we have not performed the swap, I will put the cross mark. Here we have not performed, here also we have not performed, here we performed swapping, and here also we are performing swapping. So what will happen, your 8 will come here and 78 will go here. 78 ఇక్కడికి వచ్చేస్తుంది, 8 ఇక్కడికి వచ్చేస్తుందమ్మా after swapping. So now compare, continue the algorithm and compare 23 and 8. These two we are comparing now, 23 and 8. One more time, we found that smallest element on the right hand side and largest element on the left hand side, so we need to perform the swapping. Here also we need to perform the swapping. So what will happen, 8 will come here and 23 will go here. Okay, in place of 8 we will get 23. So now 23 we got here, 8 we got here. So we completed the first pass. So as you can see, after first pass, what has happened? Smallest element from the list. After this comparison and swapping, the way how we applied the bubble sort algorithm from the end of the list, what has happened? The smallest element, it got automatically bubbled to the beginning of the list. చూడొచ్చు మీరు 8 అనేది ఏమైందమ్మా, it is automatically bubbled to the beginning of the list. Why we call this algorithm as bubble sort algorithm? In the sense, because it is something like in a bowl, of water, ఒక బౌల్లో మీ దగ్గర వాటర్ ఉన్నాయమ్మా. సో ఇన్ అ బౌల్ ఆఫ్ వాటర్, సపోజ్ ఇఫ్ వీ హ్యావ్ ది ఎయిర్ బబుల్స్ ఉన్నాయనుకోండి, ఇక్కడ బాటమ్ లో ఎయిర్ బబుల్స్ ఉన్నాయి. సో ఎయిర్ బబుల్స్ ఏమవుతాయమ్మా, ఆఫ్టర్ సమ్ టైమ్ these air bubbles, if you shake the bowl or if you keep this bowl like this only for some time, what will happen? This air bubbles slowly will come on to top, isn't it? Air bubbles ఏమవుతాయమ్మా, కొంత టైం అయిపోయిన తర్వాత automatically they will come to the top and they will what we call, they will come out of this water, isn't it? These air bubbles, they will come to top and they will come out of the water. That is how it will happen. Okay, so this is something like bubbling our smallest, the way how these air bubbles are bubbled to the top of the bowl, okay, to the surface of the water. This is also something like bubbling the smallest number to the beginning of the list. That's why we got the name bubble sort. Okay, the way how air bubbles are bubbling to the top of the bowl, to the surface of the water, in that same way our smallest number, when we apply the algorithm, our smallest number gets bubbled to the beginning of the list. Okay, gets bubbled to the beginning of the list. So now what we have to do, ma, once the smallest item, once the smallest value gets bubbled to the beginning of the list, beginning of the unsorted list, we need to move the wall, we need to move the imaginary wall one step ahead, one step mundalki move cheyali. As you can see, if this wall gets moved after the first item. As you can see here, that wall got moved from here to here now. So 8, the smallest element from the beginning of unsorted list, it is shifted now to sorted list. Sorted list this side. It is now shifted to sorted sublist. Unsorted sublist nunchi sorted sublist ki 8 ane item, smallest item shift అయిపోయింది. When you move this bubble, when you move this imaginary wall one step ahead. So doing such a thing, moving the imaginary wall one step ahead, what it has done, ma, it has decreased one item from your unsorted sublist. As you can see, previously there were 6 items in your unsorted sublist, but now only 5 items we have in your unsorted sublist. Here there were 6, but now we have only 5. And how many items we have in sorted sublist? Previously there were 0, but now it is 1. Okay, but now it is 1. So such a way we move the imaginary wall. So this is what we call the pass 1 has completed. Pass 1 has completed because one item moved from unsorted sublist to sorted sublist. So after pass 1, this is the condition of your list annamata. So now what we have to do, again for second pass, we need to apply the bubble sort algorithm from the end of the list. Okay, end of the list nunchi once again we need to apply the bubble sort algorithm. So what we do, again we compare 32 and 56, and between these two, 56 is larger and it is on the right hand side, and 32 is smaller and it is towards the beginning of the list. So no need to apply the what we call the swapping. Okay, then you go and compare 45 and 32. 45 and 32, 32 is smallest and 45 is largest, and the largest is on the left hand side and smallest is on the right hand side. Apply the swapping such a way these two gets swapped. Here you get 32 and here you get 45. Here you get 45. In such a way we need to apply the swapping. Okay, next compare 78 and 32. Again we know here you will get 78 and here you will get 32 because 32 was smaller, so we applied the swapping, these two got swapped. Next, one more time, apply the comparison between 23 and 32. Again, these two are in order. 23 is smaller, 32 is larger. So they are in order and no need to apply the swapping. Okay, so now we got 8, 23, 32, 78, 45 and 56. This is how we got this list. Okay, this is how we got this list. And as again in your unsorted sublist, again the smallest element 23, it got bubbled to the beginning of the list, so we need to move the imaginary wall ahead to complete the pass to. Okay, so once we move the imaginary wall ahead, one step ahead, it will decrease the unsorted item by one, unsorted items by one, and increase the sorted items by one. So now you can see in the sorted sublist we got two items, and in unsorted sublist we have only four items. So this is how your list will be after pass 2. Okay, after pass 2, this is how your list will be. And next, again apply the bubble sort one more time from the end of the list. Compare these two, 45 and 56, they are in order, no need to perform any swapping. Then compare one more time, 78 and 45, they are not in order, so apply the swapping. So 45 will come here, 78 will go here. So these two will be replaced with 45 and 78. Okay, next, 32 and 45, between these two, once again you apply the comparison. As you can see, they are in order. 32 left side and 45 right side, they are in order, so no need to apply the swapping. So 32 will remain here only and 45 will remain here only. So one more time, the smallest element from the list, that is 32, got bubbled to the beginning of the list. Okay, bubbled to the beginning of the list. So next thing, move the imaginary wall one step ahead. Okay, doing so will increase the item count by one in sorted sublist, and doing so will decrease the item count by one in unsorted list. So this is how your condition will be. As you can see here, both sorted as well as unsorted, they are having 3 item. Previously it was 2 4, now both are having 3 3. So pass 3 is also completed. Apply one more time the bubble sort algorithm from the end of the list. One more time, 56 and 78 will be compared, and we know 56 has to come here, 78 has to come here. So apply the swapping. Here we are applying the swapping. So 56 is going here, 78 is coming here. Then between 45 and 56, apply the comparison one more time, and they are in order. 45 has to be in left hand side and it is. 56 has to be in the right hand side and it is. So no need to apply the swapping. Now one more time, the smallest element got bubbled to the beginning of the list. So move the imaginary wall, increasing the sorted items and decreasing the unsorted items. So here, as you can see, 40 your imaginary wall got moved beyond the 45, over the 45. So here you got 4 items in unsorted sorted list and 2 items in unsorted list. So that's it, ma'am. So here only why we are stopping means because 56 and 78 already they are in order. Okay, just compare, already they are in order. So no need to do any swapping, no need to move the wall, that and all. So already they are in order. Okay, so just see 8, 23, 32, 45, 56, 78. Likewise, we got the sorted list finally. Okay, initial condition it was unsorted, but now it is sorted. So this is how we perform the bubble sort algorithm. Hopefully it is clear for you. Okay, so now we have the program demonstration for this algorithm. हेलो, मैं क्लास ले रहा हूँ। हाँ, बीच में हूँ, मैं क्लास ले रहा हूँ। एक आधा घंटा वैसा लगता। हाँ, ओके। Yeah, here you can see the flow chart for our bubble sort algorithm. Okay, as you can see, initially we are calling this function bubble sort function. It is module call. So initially we are calling the bubble sort function, and from it we are taking one loop with the current as loop counter, and here we will take another loop counter, because we need to take two loops here. When you see the code, you will understand we need to take two loops. One is the outer loop with current and inner loop with walk. Okay, this current will act like as an imaginary wall. We said na, imaginary wall. So this current variable will act like an imaginary wall, and this walk variable will perform from the end of the list. As you can see, walk initially we are initializing to size, that is nothing but last item. Okay, so this will act as a uh, uh, what we call walkthrough between the unsorted list. Okay, it will act like a walkthrough in the unsorted list. Unsorted list ni end nunchi start chesi okoka element ni compare cheyadam, that and all we'll do with the help of walk. As you can see here, when we are performing the comparison, okay, checking less than greater than, what we are doing, we are doing between walk and walk minus 1, ante last and last but one item ni manam compare చేస్తున్నాం. If they are in order, we are not doing anything. As we said na, if they are already in order, we don't have to do anything. So this straight line, this null statement, null symbol over here indicates we are not performing anything. But if they are not in order, we need to perform the swapping. Okay, swapping ఎలా చేస్తున్నాం, just list of walk minus 1 అంటే లాస్ట్ ఐటమ్ లాస్ట్ బట్ వన్ ఐటమ్ ని స్వాప్ చేస్తున్నామమ్మా. This is how we perform. Very small flow chart we have for this bubble sort algorithm. Only this much you need to draw. In your example, in your program also, if they are asking to draw the, to explain about bubble sort, this explanation you have to give, this example you have to give, and this flow chart you have, because it is an LAQ question, long answer question. In your fifth unit, all five topics, two searching techniques, three sorting techniques, all are LAQ example, LAQ questions. Okay, so that's the reason ఇది కూడా రాయాలి, ఎక్స్ప్లెనేషన్ రాయాలి, ఈ ఎగ్జాంపుల్ డెమాన్స్ట్రేట్ చేయాలి, ఫ్లో చార్ట్ డ్రా చేయాలి, అండ్ ఫైనలీ ప్రోగ్రామ్ కూడా రాయాలి. ఓకే, ప్రోగ్రామ్ ఆల్సో వెరీ సింపుల్ మా, ఈజీలీ అండర్స్టాండబుల్, జస్ట్ యూ నీడ్ టు గివ్ అ లిటిల్ ఎఫర్ట్. సో ఫర్ ఆల్ ది ఇన్సర్షన్ సార్ట్ కి ఎలాంటి స్వాపింగ్ ఉండదమ్మా. ఇన్సర్షన్ సార్ట్ ఇట్ విల్ గో ఇన్ అ డిఫరెంట్ అప్రోచ్. బబుల్ సార్ట్, సెలెక్షన్ సార్ట్ విల్ హ్యావ్ స్వాపింగ్ మెకానిజం. So in both the approaches, wherever we use swapping in sorting algorithms, wherever we use swapping, this logic only we use, this logic only we apply. So swapping ki oka particular function ni gurtu pettukunte saripotundi, oka particular function definition ni gurtu pettukunte saripotundi. And idi main function edaithe rashamo manam, in almost all the approaches, all the sorting approaches ilane untundi. What will change in the sense, here the function name will change. Here you have bubble sort. For selection sort, the function name will change, and for insertion sort, for function name will change. Okay, print array function, here you have that print array function. You can see it is also common for almost all three algorithms. Same ilane untundi print array function. ఇది ఏం చేస్తుంది ఈ ప్రింట్ అరే ఫంక్షన్ అంటే, వన్స్ ది లిస్ట్ గాట్ సార్టెడ్ నా, లిస్ట్ అరే సార్ట్ అయిపోయిన తర్వాత ఇది ప్రింట్ చేస్తుంది, దట్స్ ఇట్. సో ఇన్ ఆల్ త్రీ సార్టింగ్ అప్రోచెస్, finally we will get a sorted array, isn't it? In all three algorithms, in all three sorting algorithms, finally output ఏమొస్తుంది మనకు, ఒక sorted array నే output లాగా వస్తుంది. So this print array, what it will do, it will simply print that array. Okay, here by taking the array as input and by taking the size as input, size of that array as input, it will simply print that array, that's it. Okay, so here instead of reading the array from the keyboard, list from the keyboard, randomly here only I have initialized ma. Okay, ikkadne nenu array ni initialize chesanu. So just to simplify our program, okay, ikkadne nenu oka array ni declare chesi, variable length array ni declare chesi, number of around 7 items ni nenu ikkadne initialize chesanu. So in this case, when the variable array length is not fixed, we need to identify the size also, how many items ఉన్నాయి అనే దాన్ని మనం ఐడెంటిఫై చేయాలి. సో ఇక్కడ ఏం చేశాను, నేను ఒక సింపుల్ ఫార్ములా యూజ్ చేశానమ్మా. సైజ్ ఆఫ్ లిస్ట్, ఎంటైర్ లిస్ట్ డివైడెడ్ బై సైజ్ ఆఫ్ లిస్ట్ ఆఫ్ 0, అంటే ఒక పర్టికులర్ ఐటమ్ సైజ్. సో ఇప్పుడు ఎంటైర్ లిస్ట్ సైజ్ ఎంత అవుతుందమ్మా, ఆల్ ఆర్ ఇంటీజర్స్ కాబట్టి ఆల్ ఐటమ్స్ విల్ కన్స్యూమ్ హౌ మెనీ బైట్స్, 4 bytes each they will consume. So totally how many items we have, 7 items. So 7 4s 28. సో ఓవరాల్ లిస్ట్ సైజ్ వచ్చేసి మనకు 28 బైట్స్ అవుతుంది. డివైడెడ్ బై ఇక్కడ ఏం చేశాను నేను, సైజ్ ఆఫ్ అ పర్టికులర్ లిస్ట్ ఆఫ్ జీరో ఐటమ్, size of list of zero item. So list of zero item ante e particular item 64. So e item, it is an integer. So how many bytes it will consume? It will consume only 4 bytes. So what will be the result? 28 by 4, it will be 7. So likewise, whenever you have a variable length array of no size, okay, array with no size, whenever you have such an array, how you can identify the size in the sense by using this simple formula. Size of list divided by size of individual item. Size of the entire list divided by size of individual item will give you the total number of items in the available in the list. So here now size will become 7. Likewise, so I'm passing the complete list as well as the size of list to the bubble sort algorithm. బబుల్ సార్ట్ అల్గోరిథం కి ఏం చేస్తున్నామమ్మా, బబుల్ సార్ట్ ఫంక్షన్ కి కంప్లీట్ లిస్ట్ ని పాస్ చేస్తున్నాను యాజ్ వెల్ యాజ్ సైజ్ ని పాస్ చేస్తున్నాను. సో వాట్ దిస్ algorithm will do, what this bubble sort algorithm will do, it will sort the given list. ఈ లిస్ట్ ని ఏం చేస్తుంది ఈ అల్గోరిథం, యాజ్ ఇట్ ఈస్ తీసుకొని అన్ని ఐటమ్స్ ని సార్ట్ చేస్తుంది. ఓకే, బై ఫాలోయింగ్ ద సేమ్ అప్రోచ్ వాట్ వీ హ్యావ్ డిస్కస్డ్ ఇన్ అవర్ ప్రీవియస్ స్లైడ్. ఓకే, సో నౌ ఆఫ్టర్ వన్స్ ది లిస్ట్ గాట్ సార్టెడ్, we need to print that sorted array here. We need to print that sorted array, and print array అనే ఫంక్షన్ ని యూజ్ చేస్తున్నాము, లిస్ట్ ని పాస్ చేస్తున్నాము, సైజ్ ని పాస్ చేస్తున్నాము. సో దట్ array will print it. That array will print the list for us. Hopefully it is clear. So now here you can see bubble sort algorithm, how it is working. Yeah, very simple ma. List we took, size we took from the actual parameters into formal parameters. I said na, imaginary wall will be maintained by this current, and walk will act like a walkthrough in the unsorted list, unsorted sublist. So simply walker, it has to start from the end because our consideration for the walker will start from the end. So size minus 1 annanamma, because size is the total number of items and size minus 1 will be the last item, isn't it? So we are making our walker to stand at the end, and walker till what extent it has to continue? Up to imaginary wall it has to continue. Once it touches the imaginary wall, there only it has to stop. Walker has to stop. And walker we are decrementing because we are starting from the end, we are decrementing every time. And in every iteration, in every pass, what we are doing? Simply we are comparing the list of walk, that is last item, and list of walk minus 1. Okay, last but one item. So if this is true, list of walk okavela list of walk minus 1 kante chinnaga unte, because we want always our smallest item on the right hand side, isn't it? So it is violating that rule. So if this is true, okay, that means if smallest item is on the right hand side, we need to perform the swapping. In otherwise, if this is not true, we are not doing anything, because it is, as it is not having any else part, that means we are not doing anything. If this is false, we are not doing anything. Okay, only if this is true, if the smallest item is on the right hand side, then we need to perform the swapping of these two elements only. So list of walk minus 1 ni list of walk ni swap cheyali. So here we are calling the swap function. So this list of walk minus list of walk will go here to this swap function, and here they will get swapped. It is something like a equals to temp, temp equals to a equals to temp, and b equals to temp likewise. But we are doing through call by reference ma, because call by value formal parameters ni change cheste మీ actual parameter effect అవ్వవు. So that's the reason we are doing it through call by reference, because we passed the addresses over here, and we are receiving, as you can see, and % list of walk minus 1. This will pass the address of this particular item. Here also same thing. This will pass the address of this particular item. So when you pass the addresses, changes will be permanent. Okay, changes will affect your actual parameter as well. So your entire array will get swapped over here, I mean sorted over here, and finally after that we are printing using this print array function, we are printing the list. So you will get that list on the output screen. So quickly, let me just demonstrate this program. Okay, I have started writing my program. So what I need to include, my stdio.h only, no special programs we are going to use. No special predefined functions we are going to use. All are user defined functions only. So just include stdio.h header file only. Then now write the code. I'm saying I'm going to use swap function with two integer pointers. Okay, int star, put int star, then at the end semicolon. Then I will use the bubble sort function. It will take my integer array, that is list, and it will take integer, that is size. Okay, then I will also use print array. Okay, it will also take in list and the size. That's it, ma. Start your main, and in it declare the list. So int list of variable length equals to assign some elements, some random elements, 3, 2, 4, 1, 6, 5, some random elements, 9. Okay, some random elements I have assigned. So our goal is to get the sorted list now. Through bubble sort algorithm. So before that, we need to find the size attribute. Size ni manam telusukovalamma. So how come size of the complete list? Size of complete list divided by size of an individual item. So that is nothing but size of list of 0, an individual item. So this will give the size, and then call the bubble sort. Bubble sort ni call cheyandi. How ma? SORT, S must be capital. Bubble sort by passing the list comma size. That's it. And next thing, printing the array, because after calling the bubble sort, the list will get what we call list will be sorted. So now we need to print the list. Printf sorted array or sorted list, anything you can use, ma. Go to the end, and next is printing. We achieve through print array. Print array function use chestamamma print cheyadaniki. So to this also we need to pass the list and we need to pass the size. That's it. Then return 0. Okay, come down and write the definitions for all our functions. 3 functions we have, ma. First function is swap function, void swap. You can write any way, ma. Edaina variables తీసుకోవచ్చు ఇక్కడ. AB I will take, APTR I will take, comma, int star BPTR I will take. So now what we need to do, we just need to swap the item. So int temp I will take, then temp equals to value from APTR. So star APTR I will take, then star APTR equals to star BPTR. Okay, then star BPTR equals to temp. Like this we can swap. All items will be swapped. Okay, swap function అయిపోయింది. Next is printing array. Array printing, it is very simple, ma. Print array of what you have to receive the list, integer list of variable length, and receive the size, int size of. Same variable names తీసుకుంటున్నానమ్మా to avoid the confusion. Okay, formal, actual, same variable, same identifiers తీసుకుంటున్నాను to avoid the confusion. Now what we have to do, we need to print. So I'm taking one loop counter is declared defined. Then I equals to 0. I must go up to the size and I plus plus. So simple, printf percentile d, give some space, comma, sorry, here you give comma, what we need to print, list of I we need to print. So this is how we print the list. Printing is over now. Okay, now we need to perform the bubble sort. So return type is void bubble sort of receive the list of variable length, okay, comma, receive the size, okay, then declare your imaginary wall. and walker. Okay, two things are enough. Next, take the imaginary wall. We need to start from the beginning. So current equals to 0. Current must be less than size, and current plus plus. So this has to run all over up to the end of the list. Okay. Next, take the walker. For all walker, we must start from the end ma. So walker must be size minus 1. Okay, initialize to size minus 1, and walker till what extent it has to run, it must be less than current. Okay, walker should not touch the current wall. Okay, next is walker minus minus, it will take walker minus minus. Okay, and in it what we do, if at all my list of last item, that is list of last indexed item, list of walker, if it is less than, because always less than should be on the right hand. So if it is less than list of walker minus 1, walk minus 1, then what we have to do ma, we need to perform the swapping. So just swap these two. Okay, what, list of walk and list of walk minus 1, these two we need to swap. And swapping we have to do by passing the addresses, already I told you, because we want the effect, permanent effect on the formal actual parameters also. So that's the reason I'm calling by passing values. So this is it ma, this is it. This will do, this will swap, this will sort, this particular code will sort all the items in your algorithm, okay, in your list. So just save this. I'll give some name, uh, bubble sort 2.c. Okay, so now compile. As you can see, no errors ma. Then run it, and as you can see, the list, it is not got swapped. There is some mistake we have done. It is printing as is. Okay, list, it is not got swapped. So here touching, in the sense it should be greater ma. Walker always greater, because current will start from 0 and walker will start from size minus 1. So walker must be greater than current. Okay, less than తీసుకుంటే అసలు always it will be less only na. So likewise, so nowhere it will be less. So ఈ loop అసలు రన్ అవ్వదు, internal loop అసలు రన్ అవ్వదు. So that's the reason we got same sorted unsorted list. So now let me just check it. Okay, now as you can see, 1 2 3 4 5 6 9, all elements we got sorted. Okay, ikkada తీసుకున్న elements, ikkada వచ్చిన elements, all they got sorted. Just the problem was I took less than instead of taking greater than. Okay, that was the only mistake ma. Okay, so this is how we perform the bubble sort algorithm ma. So let me just complete another algorithm before we conclude the class. Insertion sort, hopefully we will see in our tomorrow's session ma. Insertion sort, and I will initiate asymptotic notations also in tomorrow's class. But let me just complete the selection sort algorithm. Selection sort, again, it is also one of the prominent technique in sorting your selection sort algorithm. Here also what we do, we divide the list into two sublists. Then అన్ని కాన్సెప్ట్స్ మీకు ఈజీగా ఉండేటట్లే నేను మేనేజ్ చేశానమ్మా. సిమిలారిటీ ఉండేటట్లే నేను అన్ని కాన్సెప్ట్స్ ని ఫ్రేమ్ చేశాను. సో బెటర్ ఈ నోట్స్ నుంచి మీరు ఈ కాన్సెప్ట్స్ ప్రిపేర్ అయితే మీరు ఈజీగా రాయొచ్చు ఎగ్జామ్ లో. ఓకే, అండ్ స్కోరింగ్ కూడా కొంచెం మంచిగా జరిగే ఛాన్సెస్ ఉంటాయమ్మా, బికాస్ ఐ హావ్ గివన్ ఆల్ ద థింగ్స్. ఫ్లో చార్ట్స్ ఇచ్చాను, ఎగ్జాంపుల్ డెమాన్స్ట్రేషన్ ఇచ్చాను, థ్యూరీ నోట్స్ 5-6 పాయింట్స్ ఇచ్చాను. సో యాజ్ ఇట్ ఈస్ ఇలానే రాయండి. ఇఫ్ దే ఆస్క్ యూ టు రైట్ అబౌట్ సెలెక్షన్ సార్ట్ నా, రైట్ దిస్ 5 పాయింట్స్, write this example demonstration, write this algorithm, flow chart, and write this program. That's it. Okay. So selection sort algorithm, it will also divide your list into two parts, that is sorted list and unsorted list. Okay, sorted and unsorted list, and between the sorted and unsorted we maintain an imaginary wall. Okay, so what we do is, from the unsorted sublist, we somehow identify the smallest element ma. ఇక్కడ మనం స్మాలెస్ట్ ఎలిమెంట్ ని బబుల్ చేయము టు ది బిగినింగ్ ఆఫ్ ద లిస్ట్, లైక్ యువర్ బబుల్ సార్ట్. We will not bubble the smallest element to the beginning of the list. Instead, what we do, we just identify the smallest element from the unsorted sublist. And once it is found, once the smallest item in the unsorted sublist is found, what we do is, we swap that smallest element with the element in the unsorted sublist. Okay, so what we do, the smallest element from the unsorted sublist is found and swapped with the element at the beginning of the unsorted sublist. Simple గా మనం ఏం చేస్తాం, లిస్ట్ లో అన్సార్టెడ్ సబ్ లిస్ట్ లో స్మాలెస్ట్ ఎలిమెంట్ ని ఐడెంటిఫై చేసి అన్సార్టెడ్ సబ్ లిస్ట్ లోనే ఫస్ట్ ఎలిమెంట్ తోటి స్వాప్ చేసేస్తాం. అక్కడ ఏం చేశాం, స్మాలెస్ట్ ఎలిమెంట్ ని స్టెప్ బై స్టెప్ బిగినింగ్ కి పుష్ చేశాం. Okay, just like bubbling. But over here we are not doing ma. We are identifying the smallest element and we are swapping with the first element of the unsorted sublist. Okay, so this is how we are achieving that task. So once the smallest element is swapped, okay, because here why the name selection, because smallest element we are selecting, it is like an selective approach, it is not bubbled, it will be selected. So that's the reason the sorting algorithm name we got selection sort. Okay, so after each selection and swapping, what we do ma, we move the imaginary wall between the two sublists. Okay, we move the imaginary wall between the two sublists one element ahead. Okay, so doing so will do what, it will increase the number of sorted items in the sorted list and it will decrease the number of unsorted items in the unsorted sublist. That is what will happen. Okay, simply the sorted list లో sorted element count పెరుగుతుంది and unsorted list లో unsorted element count decrease అవుతుంది. Hopefully it is clear ma for you how we are doing. And each time an element is moved from the sorted unsorted list to sorted list, what we call it, we call it as one sort pass is completed. Same like your bubble sort. Bubble sort lo kuda alane annam kada. Every time we are moving one item from unsorted sublist to sorted sublist, we are saying that one sort pass we are completing. Okay, one sort pass we are completing. And with a list of n elements, at most how many sort passes we need ma? N minus 1 sort passes we need. If you have n elements in your list, you need n minus 1 sort passes before you will get the sorted list. Okay, so this is your example demonstration. Here you can clearly see, initially we have all items in the unsorted sublist only, and your imaginary wall is standing at the beginning of unsorted sublist. So your sorted sublist, it is not having any items. As you can see, it is not having any items here. 0 items in sorted sublist and all 6 items in your unsorted sublist. Okay, so now what we are doing ma, in your original list we are applying the logic of identifying the smallest element. We know how to identify the smallest element in an array of elements. It is very easy ma. Okay, so smallest element ni identify chestamu and smallest element ni identify chesin tarvata we will swap that smallest element with the first element of the unsorted sublist. Okay, we'll swap the smallest element in the unsorted sublist with the first element of the unsorted sublist. So these two will get swapped. Here what will happen, these two will get swapped. Okay, ee rendu swap ayipothayamma. So what will happen, here you will get 8 and this 23 will come here. Okay, 23 ఇక్కడికి వచ్చేస్తుంది, 8 ఇక్కడికి వెళ్ళిపోతుంది. Okay, so after swapping 8 with the first element of the unsorted sublist, what we have to do, we need to move the imaginary wall. So this is the time to move the imaginary wall. So your imaginary wall will move from here to here. It will come here like this. It will come imaginary wall ikkadiki vachesthundi. As you can see here, we have that action. Okay, your imaginary wall is here and we got 8 here. Okay, we got 8 here. So after moving the imaginary wall, what has happened? Your sorted list element count got increased by 1. Now it is 1. And your unsorted list element count got decreased. It is 5 now, as you can see. Okay, so this is what we call, after moving the wall, imaginary wall one step ahead, we call our pass 1, sort pass 1 is completed. So this is what we got after sort pass 1. Again, what we need to do in the unsorted list to perform the second pass, again you need to identify the smallest element, and we know the smallest element is 23. So we have to swap this smallest element with the first element of the list. Okay, first element of the list is 78. So now what will happen? This 78 will come over here, 23 will come over here. So now you get 23 here and 78 here. Okay, so now once you swap, you need to move the wall, imaginary wall. So imaginary wall will come here like this. Imaginary wall will come and we complete our pass 2. So this is what you will get after your pass 2. So you can see here, your imaginary wall is after 23, 8 you have here, and remaining 78, it came to this particular location. Okay, hopefully it is clear. Now what you have to do, again you need to identify the smallest element, and we know 32 is the smallest element. So this 32, one more time, need to be swapped with the first element of the unsorted sublist. So this 32 will be swapped with 45. So 32 will come here and 45 will come here. Okay, 45 will come here. Okay, no more 32 and 45. Here 32 will come and here 45 will come. And after swapping, this is swapped. Every time we are performing, no more comparison. Straight away, after finding the smallest element, every time we are performing the swap. So now, after swapping, move the imaginary wall one step ahead. This approach, me BubbleSort approach ki completely different ma. Don't confuse between the two approaches. Okay, now the wall got moved. So your third pass, after third pass, your scenario will be like this. Okay, so we got 8, 23, 32 in sorted sublist, and we have 78, 45, 56 in the unsorted sublist. So identify the smallest element in the unsorted sublist. We know that 45 is unsorted, smallest element in the unsorted sublist. So swap this 45 with the first element of the unsorted sublist. Okay, so now what will happen? 45 will come here and 78 will come here like this. Okay, then after swapping, move the imaginary wall one step ahead. So imaginary wall will come here. So after pass 4, this will be your scenario. 8 to 20. So moving the wall increased one element in the sorted list and decreased one element in the unsorted list. So we got 8, 23, 32, 45. So now what we have to do? 78 and 56 we have. So 78 and 56, these are the elements in unsorted sublist. Identify the smallest element. We know that 56 is, we can see that 56 is smallest element. So just swap it with 78. So these two will get swapped. 56 will come here, 78 will come here. Okay, so now no more 78, just 56 will come here and 78 will come here like this. So now as you can see, after doing this, yeah, even if you move, only one element will be left out in unsorted sublist. So instead what we do, we'll complete our sorting process and we'll get our final sorted list, as you can see. Okay, 8, 23, 32, 45, 78, sorry, 56 and 78. Likewise, we got all our elements in sorted order. This is after pass 5. So how many passes it took? Around 5 passes it took. Okay, before we get the sorted list. So as we have n equals to 6 elements, that's the reason it took n minus 1 sort passes. N minus 1 sort passes, that is nothing but 5 sort passes it took. 5 sort passes it took before giving the final sorted sublist, final sorted list. Okay, hopefully you understood the concept. Selection sort, very simple concept, ma'am. All the approaches, all 5 approaches, they are very simple. Just we need to work on them, just we need to do some practice on them. Okay, so hopefully it is clear. So quickly we go and we demonstrate the uh, uh, algorithm, other is flowchart. Here also same thing. The current thing will maintain the imaginary wall. ఈ కరెంట్ వేరియబుల్ ని ఎందుకు యూస్ చేస్తామమ్మా? టు మెయింటైన్ ది ఇమాజినరీ వాల్ బిట్వీన్ సార్టెడ్ అండ్ అన్సార్టెడ్, అండ్ దిస్ వాక్ విల్ యాక్ట్ లైక్ అ వాక్ త్రూ. And from where we are passing, from where we are starting, current plus 1. This time we are not starting from the end, as you can see. Simply we are starting from current plus 1. Current అనేది ఫస్ట్ ఎలిమెంట్ దగ్గర ఉంటుంది, అండ్ కరెంట్ ప్లస్ 1 అనేది సెకండ్ ఎలిమెంట్ నుంచి స్టార్ట్ అవుతుంది. ఓకే, సో సెకండ్ ఎలిమెంట్ నుంచి మనం స్మాలెస్ట్ ఎలిమెంట్ ని ఐడెంటిఫై చేసి స్వాప్ చేస్తాం. Okay, here we are simply checking and we are making the smallest as walk. Okay, if this is true, we are making the smallest as walk, and we identify the index where we have the smallest element. Okay, your smallest will become the index holding the smallest element. Okay, so after finding what we do, we simply swap. Here you can see exchange current and small. It is saying it is nothing but we are swapping the two elements. Okay, so that is how we are applying our selection sort algorithm. Here you can see the what we call program for selection sort. As I said now, many much of the code, it is very similar to your BubbleSort. Your swap function is same like your BubbleSort. Your print array function, it is also same like your BubbleSort. Your main function is also same like your BubbleSort, only with the name difference. Previously it was BubbleSort here, but now as we are applying selection sort, the name got changed and it is selection sort over here. The remaining complete program is same, only is selection sort thing change avutundi. And when I do this thing, there also I will show you how it will change. Okay, how it will change, adi ela change avutundo meeku akkadne chupistanamma. Okay, so simply what we have to do here in our program, we no need to change much. We need to change only the algorithm name. That is now it is selection sort, not the bubble sort. So in all 3 locations, declaration, definition, initialization, in all 3 locations I will make it as selection sort. ఓకే, నేమ్ ని చేంజ్ చేశానమ్మా. దిస్ ఇస్ ఫంక్షన్ డిక్లరేషన్. డిక్లరేషన్ లో నేమ్ ని చేంజ్ చేశాను. కాల్ చేసేటప్పుడు కూడా ఇక్కడ బబుల్ సార్ట్ అని ఉంది కదా, కాల్ చేసేటప్పుడు కూడా నేను సెలెక్షన్ సార్ట్ గా కన్వర్ట్ చేశాను. అండ్ డిఫైన్ చేసేటప్పుడు కూడా హియర్ వి హావ్ బబుల్ సార్ట్, సో ఐఎమ్ మేకింగ్ ఇట్ యాజ్ సెలెక్షన్ సార్ట్. అండ్ దిస్ ఎంటైర్ కోడ్ వి నీడ్ టు చేంజ్, సో ఐఎమ్ సింప్లీ డిలీటింగ్. ప్రింట్ అరే సేమ్ ఉంటుంది, స్వాప్ సేమ్ ఉంటుంది, మెయిన్ ఫంక్షన్ కూడా సేమ్ ఉంటుందమ్మా. నథింగ్ విల్ చేంజ్. So I'm considering the same array list, same list, and I'm considering the size. And here, when you are passing the list and size, just pass it as -1. That is the only change. Okay, pass it as -1 here. That is the only change. And now we write the algorithm for selection sort. Here we need to declare 3 items, integer, your current, your imaginary wall, and your walker, and your SMLST, smallest. Okay, smallest ni kuda oka extra item ni తీసుకుంటాం, oka extra index ni తీసుకుంటాం, smallest ani. So we start our imaginary wall from the beginning, from the 0th, and it should run till the size. Okay, and it should increment by 1 every time. So this is your imaginary wall. Okay, in it initially we consider the smallest as current only in the beginning of the list only. Okay, because we need to start from somewhere na. So first item e manam smallest item ankoni start chestamu. Okay, then what we do for all, from the second item, walker ekkadi nunchi start chestam, from the second item. So that is current అనేది first item plus 1. From the second item till what? Till last item. So walker must be less than size here also. Okay, walker must be less than size. Okay, and then walker plus plus 1. Walker plus plus, and coming to it, and here we need to do the comparison of the complete array. So that is a walker, list of walk. It must be less than list of what? SMLST. ఏదైతే స్మాలెస్ట్ ఐటమ్ మనం అనుకున్నామో ఆ స్మాలెస్ట్ ఐటమ్ కంటే లిస్ట్ ఆఫ్ వాకర్ ఒకవేళ స్మాల్ అయితే సింప్లీ చేంజ్ యువర్ ఎస్ఎంఎల్ఎస్టీ స్మాలెస్ట్ నే వాకర్ గా చేంజ్, వాకర్ ని స్మాలెస్ట్ గా చేంజ్ చేసేయండి. Because now your if this walk item, if it is less than SMLST, there is no meaning of SMLST being small. So what we need to do, ఈ కేసులో మనకు వాక్ స్మాలర్ అయిపోతుంది. సో మనం SMLST ని వాక్ నే SMLST గా కన్వర్ట్ చేసేస్తాం. సో దట్ ఈస్ హౌ. సో ఆఫ్టర్ దట్, after coming out of this loop, once you get the smallest item in the complete list, we need to change with the current. I mean that is beginning, isn't it? So swap the SMLST item ampersand list of smallest, okay, list of smallest, comma ampersand list of what? List of current. Like this you perform the swapping. Okay, that's it. Very simple code ma for performing what we call selection sort. You just need to understand and just need to remember. Current ante imaginary wall, walker ante walk through between your unsorted list, walk through cheyadaniki walker ni use chestam. Okay, current ante this is nothing but imaginary wall ma. Every time whenever we perform one pass, a particular inner loop will perform one pass, one sort pass. One sort pass perform చేశామంటే మనం imaginary wall ని move చేయాలి. So how we are moving? Just by incrementing plus plus, just by incrementing it. So imaginary wall move అవుతూ ఉంటుంది. So save this, perform compilation, successful, perform execution. As you can see, again we got the list, sorted list. Okay, so here we had the unsorted list, but now we got the sorted list. So just to have the difference between selection and bubble, because we didn't see any difference now. So what I'll do, I'll take some different elements, 5, 2, okay, 8, 11, 4, 8, 11, 1, 63, likewise some elements I have taken, 6 elements I have taken. Any elements you can take, it will simply sort, because variable length array తీసుకున్నాము and size ని కూడా random గా calculate చేస్తున్నాము. Based on the array size only, size ni calculate చేస్తున్నాము. So any number of items you can take, it will simply swap. Okay, now I need to compile it first. Compilation successful. Now execute. As you can see, it got swapped. 1, 2, 5, 8, 11, 63. All items they got sorted. Okay, all items they got sorted using the selection sort algorithm. Hopefully the concept is clear for you. Yeah, here only I'm concluding my session. In tomorrow's session, we will see insertion sort and followed by the asymptotic notations. Okay, with that we complete your 5th unit. Okay, tomorrow's class and day after tomorrow's class. Hopefully, in 2 more classes, I will conclude your 5th unit. Thank you very much, students.